Okay, guys, we're going to look at the zeros of polar curves and the maximum of polar curves. So when do I have a zero of a polar curve? It's when the radius of curve is equal to 0. So in other words, when r is equal to 0. Okay, so for our first equation, we're going to set r equal to 0 to find the zeros. Okay, finding zeros. So 0 is equal to 3 cosine 2 theta, and then we just solve for theta, so divide by 3. 0 is equal to cosine 2 theta. I'm going to do the cosine inverse of 0 is equal to 2 theta. Remember, this is my angle. So cosine is equal to 0 at pi over 2. So when 2 theta is equal to pi over 2, and when 2 theta is equal to 3 pi over 2, and then we have to add our 2 pi times n. Okay. Then divide by 2 to get theta by itself. So theta is equal to pi fourths plus pi n, and theta is equal to 3 pi fourths plus pi n. Okay, you know what? We're going to find all the zeros between 0 and 2 pi for theta. Okay, so I'm going to go ahead and look at my first equation. I can see that theta can equal pi fourths plus pi would give me 5 pi over 4, and then plus pi would give me 9 pi over 4. That's too big. Okay, second equation. So 3 pi over 4 plus pi gives me 7 pi over 4. So I see these are answers and these are answers. Okay, so I know that I'm going to have zeros at the point 0, comma pi fourths, 0, comma 5 pi over 4, 0, comma 3 pi over 4, and 0, comma 7 pi over 4. Okay. Next, at what angles will there be zeros for this new equation? So again, we're going to set r equal to 0. So I get 0 is equal to negative 3 plus 2 sine theta. Add 3, divide by 2. I have 1.5 is equal to sine theta. And I'm like, sine inverse of negative 3 over 2 is equal to theta. And I get an error because 1.5 is not in sine's domain. So, therefore, there are no zeros for this function. All right, the other key feature we need to evaluate is our maximum values. So we're going to look at when we have maximum values. It's like, so maximum value in a curve, polar curve, is when the curve is the max distance from the pole, which is the origin in this case. Okay, so on a polar curve, the pole is right here, the 0. So if I have, say, a rose, we're going to have a max distances at the ends. That's a bad color. The ends of the curve, the maximum distance away from the pole. Okay, that's the pole. All right, so we have to do a little evaluation here. So if I look at this, r is equal to 2 cosine 2 theta, I want to think like, okay, so for cosine 2 theta, cosine's outputs oscillate between, let's see, cosine's outputs oscillate between -1 and 1. So 1 and -1. So I want to figure out when cosine is basically equal to 1, and that will give me my maximum value. So when is the cosine of 2 theta equal to the absolute value of 1? Because actually we want when the r is equal to the absolute value of the max value, max distance. Okay, so I'm going to split this up. The cosine of 2 theta is equal to 1, or the cosine of 2 theta is equal to -1. So I get cosine inverse of 1 is equal to 2 theta, and the cosine inverse of -1 is equal to 2 theta. So 2 theta is equal to, well, cosine is equal to 1 at 0 and at 0 plus 2 pi n, okay? And then cosine, so then divide by 2, so theta is equal to 0 plus pi n. So on the interval from 0 to 2 pi for theta, we get thetas are equal to 0 and pi, and then 2 pi, but 2 pi is out of our range. For this equation, the cosine inverse of -1 is equal to pi plus coterminal angle. So 2 theta is equal to pi plus 2 pi n divided by 2. So theta is equal to pi over 2 plus pi n. So finding our angles in our range, it's pi over 2 and 3 pi over 2. And that's when we will have maximum values. Okay, so the last one, again, we have to look for the maximum values. So I can see that I'm adding two things together. So if I have, I'm going to think, what are the outputs I could get for the sine ratio? The r's could be between -1 and 1. So if sine was 1, so if I have -3 plus 2 times 1, that would give me -1. If I have -3 plus 2 times -1, that would give me -5. The absolute values of this one is larger, so I'm going to look for when sine of theta is equal to -1. Okay, so sine inverse, so some of this takes a little bit of intuition. Okay, so sine theta is equal to, or sine inverse of -1 is equal to theta. So I get theta is equal to 3 pi over 2 plus 2 pi n. But if I'm looking for thetas between 0 and 2 pi, the only answer I get is theta is equal to 3 pi over 2. Okay? When I plug this back into my equation to check, r is equal to -3 plus 2 sine of 3 pi over 2. I get -3 plus 2 times -1, which gives me a radius of -5. I have a maximum point at a radius of -5, and the angle is 3 pi over 2. Where would you graph that? Well, I would graph that looking down at 3 pi over 2, but then walking backwards towards pi over 2. That would be right there. Okay, and that is that.